Hello, my name is Mike Guy, and in this video we are going to be looking at a more advanced demo of the Sprite Struct that we created in our previous video. Now there's going to be a lot of code in this example, and I have a lot of code already started here, so let me just go over it real quick. First thing you're going to notice is that I have my width and my height as global, and that's going to help me with some of the things I'm doing here in this demo. I don't usually condone globals if they can be avoided, but in this case it's a simple program and I don't want to fret too much about that. Also, I have the Allegro font headers included here, so we can do some outputting to the screen. That way we can get an idea of how much, if at all, we're taxing the system. Alright, and so I have the Sprite Struct here. We saw that last video, so I'm not going to go over it. We do have a few new variables here. One is this float game time. What we're going to do is we're going to output the frames per second. We know it should be 60 because we have our timers, but I want to verify. I want to see if I'm taxing my system or not. And so we just have two helper variables here, frames and game frames per second, which will tell me what our actual frames per second are. So I'll cover these a little bit better when we get to that spot. So I'm just going to leave those right here for now. I have my font. I am loading my font add-ons. I'm loading my font. And then I'm loading a sprite sheet called spacecore.png. Now you haven't seen this one before. I got it off this site right here called makeyourflashgame.com. And it's basically a floating orb. We're going to look at that here. But I'm loading that in. It offers more frames of animation than our previous dragon. And so I'm going to use that because it's a really cool animation sequence anyway. Alright. Then I have basically just, you'll remember this from when we talked about timing. The render equals true if render and AL is event queue empty, so that we can see if we're taxing the system at all. And then finally, just destroy my image and destroy my font. Okay, so with that set up, we can go ahead and get to work here. I could put all of my code inside of my main here. What I'm going to do is I'm going to create three functions to kind of separate the code for us, kind of modularize that. And to kind of help out and keep our main less cluttered, more organized. So these functions are going to be init sprites, and init sprites is going to take basically an object by reference of type sprite, and then it's going to take an image, our Allegro bitmap named image, and then we have another function that's going to be update sprites, and that's going to take a sprite object by reference. Now normally too, if I had a sprite class, these functions would just be part of the class and I wouldn't need them. But since I don't have a class, I'm doing this with structs, we're just going to create these helper functions here. And I'm going to do draw sprites, to type that way long, draw sprites, and that's going to take a sprite object by reference. Alright, okay. And so I'm actually just going to copy these headers. So I don't have to type this all in at the bottom here. And I'm going to come down past my main, and I'm going to paste that. Alright, so we can get to work there. And so what I want to do is, first off, I'm going to do init sprites, and then we're going to go ahead and plug everything in. So init sprites, the job of init sprites is to take a sprite object and give it all of its starting values. And if I was making a game based on this is where I'd put all my game specific information. So this isn't generic at all. This is specific to the very situation in which I'm programming. And so I'm going to type sprite.x, and here I'm going to make it random. Alright, I want my sprites to be in a random location on the screen, just so I don't have to plot them around. So I'm going to do width -20, +20, just to kind of give it an offset centered, positioning. I just don't want it to be right up against the borders. And then I'm going to do sprite.y equals rand. I'm going to do height -20. This is why I made width and height global, by the way, just so I didn't have to pass it into this function. And then I'm going to do sprite.velocity x is going to equal rand. So my velocity is also going to be random, and it's going to be 7 plus 2. and then I'm going to do sprite dot velocity y equals rand, and that's going to be 7 plus 2 as well. So random speeds here. Then I'm going to do my direction. I'm going to do sprite dot direction x is equal to -1, and sprite dot direction y is equal to -1. I could make those random as well, but I don't care to. We're just keeping this real simple. You'll also notice that I don't see the random number generator. So every time I run this, it's actually going to run exactly the same, but I don't care. This is just a demo, so not a big deal. Then I'm going to do sprite dot max frame, and this is the reason I use this sheet. Before, our max frame was 8 because we were just sort of stripped, but in this one, our max frame is actually 71. All right, so we have a lot of frames with this animation, and so I'll get to show you guys what the two mathematical sequences are to find our positioning in this much larger sheet here. Then I'm going to do sprite current frame is going to equal 0, and then sprite frame count is equal 0, and sprite frame delay. I'm making it 5. If I wanted it to animate faster, I could make it a lower number, like 3. Then I'll do sprite frame width. In this case, I know that they're 64 apiece. Sprite dot frame height also is 64 apiece. And then sprite dot animation columns. Now, while they have 71 frames of animation, there are 16 columns. And then I'm going to do sprite dot animation direction equal to 1. Oh, yeah, there we go. And then finally, sprite dot image is going to equal the image that I passed in, which is why that's there. So I can pass in an image and set it into this sprite. Alright, great. So that will initialize all of our sprites for us. So now let's look at how we're going to use that. I'm going to come back up here into my main, and I'm going to create some a helper variable and then my array here. So I'm going to do const int and then num sprites. And we're gonna be real conservative here to start. I'm gonna say one sprite. All right, and then I'm gonna make an array of sprites named orbs of size num sprites. So I would effectively be size 1. It may not seem like much, but just wait. Great. Okay, so we have all of that, and now after I load in my image here, right here where I load in this spacecore.png, I'm going to go ahead and initialize all of my sprites. So since the init sprite function just took a single sprite object, I'm going to go ahead and do for int I equal to 0, I is less than num sprites plus, and then I'm going to call init sprites, and I'm going to pass in orb sub I and image. Great. And that'll initialize all of my sprites for me. So far so good. You know, we've created an array of sprites, and we're initializing all of them to some random and some known values. Fantastic. Okay. Next, we need to worry about updating our sprites. So I'm going to create the function first, and then I'm going to come back and plug it in. So I'm going to come down here to where we have update sprites, and let's just get this ready here. Okay. So once again, we're taking a single sprite object, and we're going to go ahead and plug in our animation, our movement, and our bounds checking. Now, the functions I'm going to use here, or the actual code, is going to be the exact same as the previous example, except now I'm using the name sprite instead of dragon. So I'm going to do if ++ sprite dot frame count is greater than or equal to sprite dot frame delay. That means it's time to update our animation. I'm going to say sprite dot current frame plus equals sprite dot animation direction, and then our if statements: if sprite dot current frame is greater than or equal to sprite dot max frame, sprite dot current frame 0, else if frame is less than or equal to 0. That space away there. Sprite.currentFrame is going to equal Sprite.maxFrame minus 1. Alright, and then Sprite.frameCount equals 0. Okay, so that's our animation, nothing new here, and then I'm going to do Sprite.x plus equals Sprite.velocityX times Sprite.directionX and Sprite.y. When that's supposed to be plus equals Sprite.velocity y. Tell you what, all this Sprite is making me thirsty. Sprite.direction y. Great. Okay, so we've handled our animation, nothing new here. Our motion, nothing new here. And we're just going to do our bounds checking. Now, before we wrapped around when we were doing our bounds checking, now we want to bounce off the walls. And bouncing off the walls is a matter of testing where we currently are and also which direction we're going. So we can be sure to bounce off in the right direction, and so we don't freeze into a wall by trying to reverse the direction, over and over and over and over again, because we're kind of in that stuck mode. And you could fix that by kind of adjusting the X position, but I'm not going to bother to keep it a little simpler here. Another reason I'm going to basically just test the direction as opposed to setting the actual Y outside of the bounds of the border is so that I can have one if statement to treat both extremes, either they hit the left side or the right side. So I'm going to program it just a little bit generically. So I'm going to say if, and then I'm going to have a second, we'll just create some parentheses like this, keep them separated out. If sprite.x is less than or equal to 0, and sprite.directionX equals -1. All right. So we're saying, if it hits the left side and it's going in that direction, or I'll create a second parentheses here, or if sprite.x is greater than or equal to width minus sprite.frameWidth and sprite.directionX equals 1. There we go. And then I'm going to bring that parenthesis back. Okay, so that's our complex if statement. If that's true, then we've hit a bounds and we're heading towards that bounds. I'm going to say sprite.directionX times equals -1. We're just going to reverse the direction, and I'm going to do sprite.animationDirection times equals -1. So if we collide with something, we're going to start rotating in the opposite direction. Alright, great. So that's the left and right. Now we need to handle the top and the bottom. So I'm going to say if, and then I'm going to say if sprite.y is less than or equal to 0, and sprite.directionY equals -1, or sprite.y is greater than or equal to height minus sprite.frameHeight, and sprite.directionY equals 1. Alright. And then I'm actually just going to copy this, pop that down there, because all I have to do is then just change direction X to direction Y. Okay. And that's it. That's all my updating. So I'm doing my animation updates, I'm doing my positional updates, and then I'm doing my bounds checking. So let's go ahead and get this plugged in now. So all I'm going to do is I'm going to come up here to my update section right here, and I'm going to do for int I equals 0, I is less than num sprites, I plus, and then I'm going to do update sprites, and I'm going to pass in orbs sub I. Great. Okay, so we just have one more step. We have our initializing, and we have our updating, and finally we have our drawing. And we're going to go over a little bit of a special math for you here. And I'm going to come back down here to my draw sprites. And what I want to do is this, is since we have multiple rows now I need to be able to draw both the column and the row of my sprite sheet. So I'm going to create two variables here. I'll start with fx for our frame x, and that's going to be sprite.currentFrame modulus, okay, because we want the remainder of the division. It would help if I typed incorrectly there. Modulus sprite the total number of columns, or animation columns. So that'll tell us if we're in column 0, 1, 2, 3, 4, until we get to, like, until we loop around over again, 0, 1, 2, 3, all the way up to max for our animation columns, then again and again and again, times sprite.frameWidth. Alright, so that's going to essentially tell us, basically, so if we are in current frame 0, this will be 0. 0 times frame width is 0, so we're at the 0. And since this has 16 animation columns, once we get to 16, all right, current frame module 16 will be 0 again. So we've looped back around into the next row. And then 32 will loop back around in the next row, so on and so forth. So that's our x, and now I'm going to do int fy is going to equal sprite.currentFrame. And now I'm doing division, just give me my remainder here. And then I'm going to do division sprite.animationColumns times sprite.frameHeight. And since it's integer division, if I'm on current frame 1 through 15, 1 through 15 divided by 16 is a decimal point, or a fraction, which will get rounded to 0. Then once I hit 16, we're at 1. 16 to 31 will round to 0. Then I hit 32 and I get 2, and so on and so forth. And so you can see we can narrow down our grid location using these two variables. And once we have that, all we have to do is draw it. Draw bitmap region. Alright. And I'm going to do sprite.image. My starting location is going to be fx and fy, and then sprite.frameWidth. And right here is sprite.frameHeight. And then sprite.x, sprite.y, and 0 for flags. Great. And that is everything we need to know about drawing from the sprite sheet. And you'll notice here now we can draw not just a single row, but multiple row animation. So I'm going to come back up here to our game loop, and I'm going to sit here and draw each one of these. So I'm going to say for int I equals 0, I is less than sprites I plus. Alright. And then I'm going to say draw sprites, and I'm going to pass orbs sub I. And one more. Great. Okay. Now, we have that font stuff for our frames per second. I'm going to skip that for right now. I just want to make sure this runs. We want to see this run. And so what we have is we have our orb animating, and this time around it's having to be going kind of fast. You'll see how every time it hits, the animation reverses. Maybe you can't see it. It's going kind of fast, and my recording software may not be capturing that. But if you're following along, you will see that the animation is reversing every time it collides with something here. Great. Okay, so our program is working. It's working more or less generically, all with the exception of the init sprites function. And so you can see our helper functions, our updates, and our draws are good to go. These functions are making this work for us. Now, what I want to do is before I start amping this up, I'm going to go ahead and add in some capability of testing how fast I'm going. So what I want to do is every time my system updates, right, every time Allegro event timer fires off, I want to do two things. First off is I want to do frames plus plus. Right? That means another frame or another tick or another cycle of my game engine has happened. Okay? The theory is that every 1 second, frames should have the opportunity to cycle 60 times. Alright? So our frames per second is 60 frames per second. This number should equal 60 every 1 second. And we can test that. We're actually going to write in the condition for that. I'm going to say if al current time, that's the function that tells me how many seconds since init has been called has passed, minus game time is greater than or equal to 1. What that means is if the current time less the time it was when we started, or when we initialized this value, which we haven't yet, we will in a second, is greater than or equal to 1 second has passed. Alright? So if that is true, then I'm going to do game time equals al current time. We're going to reset this value so it won't fire off again until another second. And then we're going to do game fps is equal to frames. That's just going to be our container. And then I'm going to do frames equals 0. We'll reset frames. Okay. So we have this working great. What I want to do is, like you said, or like I mentioned a second ago, we haven't initialized that yet. What we're going to do is we're actually going to come up to right after we call our start timer, and I'm going to do game time equals al current time, just to kick things off right. Great. So now our timing counts, it's in there, and then the last thing we want to do is we just want to write it to the screen. So I'm going to do al draw text f. And my font is going to be font 18, and my color is going to be al map RGB 255 0255. Should be that nice obnoxious color, easy to see. My x and y, I'm just going to do 55. I want it to be on my upper left hand corner. No flags, and then my text is just going to be FPS %I for our integer placeholder, and then game FPS. And you'll see when we run this, we see 60 frames per second. Oh, we got 61 that time. So our timing is pretty darn close. Every once in a while we'll sneak an additional frame, but I guarantee it's not noticeable. So great. So now we can start really amping up this this demo here and seeing how it affects our system, or how it doesn't affect our system, as you will. Well, we'll see here in a second. So what I'm going to do is I'm going to come up here to number of sprites, and I'm going to make it 100 sprites. Alright? Now you'll notice I'm not doing anything else, just changing num sprites. You're going to see that all of a sudden I'm going to have 100 sprites. I'm going to run this here, and all of a sudden, look at that. 100 sprites moving at different speeds, bouncing all over the place. And you'll notice still 60 frames per second. Alright, so good. So now we have 100 objects, all moving, all updating, all animating. Every single one of them is animating. And here's the cool thing, is they're animating independently of each other, right? They're each their own entity, right? With their own variables, their own recording, In previous examples, when we had just the X and Y and the current frame and the frame delay variables that were just declared in main, we would have to have like X1, X2, X3, X4, to keep track of the position of all of these all the way up to X100, So putting it into a sprite struct removes the need to do that. But 100 is so achievable. Let's try 1,000. Or better yet, let's try 10,000. Oh, there we go. 10,000 sprites, all animating independently of each other. Right, moving and bounce checking and everything. And notice this, not even budging our frames per second. Alright, pretty neat. And so 10,000, that's doable. Let's go with 15,000. Great, 15,000 items, all not touching our frames per second, all animating independently. So now, really, really, really cool. Okay, you're seeing here, we're able to animate 15,000 sprites on the screen at the same time without slowing our game down. Now, I would take this to the extreme, to the point where it starts impacting my system. However, since I'm using a basic array, if I go above 15,000, I actually get a stack overflow. And I don't want to adjust my compiler settings and line up with settings that you may not have. And you may have already gotten a stack overflow at 15,000. It's compiler specific, so basically just note this really isn't affecting my system at all. And that's good enough for me. So we've got 15,000 sprites animating. So that's pretty good. Most games, I can't imagine any game that's going to have that many objects on the screen at the same time. So pretty slick. Okay, great. So that is my Sprite Struct demo. And you can see how just by changing the number of that array, everything else just gets bigger and bigger and bigger. In the next example, I'm going to tone it down a notch, but we're going to do something really cool. We're going to look at having each sprite move relative to every other sprite, and something I like to call my gravity demo. And so you will see that here in the next video.